So for this practice problem, we're going to use Taylor polynomials to find values of functions with 3 variables. And in this problem, you are going to find the value of the point 1.1, 1.1, 2.1 using a second order Taylor polynomial. So I am going to go through and explain how to do this. So if you want to try it for your own, I suggest pausing the video. So first, what you want to do is find the value of the function at the point 1, 1, 2 because it's relatively close to the point that you're trying to find. And you want to do this because your 0th order Taylor polynomial is just a line that goes through the point f of 1, 1, 2. And that is equal to 5. And that line is horizontal, so it doesn't really give you an accurate approximation. If you want a more accurate approximation, you could go to the first order Taylor polynomial. And what you do is you want to find the partial derivatives with respect to x, y, and z of the top function, and you can just plug those into the formula, and then you just multiply them by x minus 1, y minus 1, and z minus 2, because like the formula shows, this is the change in distance that you're going, whether it's in the x direction, y direction, or z direction. If you want to have an even more accurate approximation, you would go to the second order polynomial, which is just the first order polynomial plus the next step in the formula, which is taking the second partial derivative with respect to x, y, and z, and you have to make sure you divide it by 2, because you have to undo the power rule. And then you have to also make sure that you're getting the correct exponent, because this is a second order polynomial, so you'll have a 2 as your exponent. And as you evaluate each of them at the point 1, 1, 1, 2, and then you plug in 1.1, 1.1, and 2.1 at these points. So the 1.1 goes here, 1.1 goes here, and 2.1 goes here. And the 112s go where all of the partial derivatives are. So there, there, and there. And if you evaluate them at the point, you'll see that you keep getting more and more accurate as you keep adding like second order, third order, fourth order, but we can't really go past the second order because we will run out of exponents. So you can see that you keep getting closer to the actual value of point 1.1, 1.1, 2.1, and that is 6.1182. And the closest you can get is using the second order Taylor polynomial, which is 6.04. So it is a pretty close approximation.